Welcome back, everybody. Special on the move version of Mr. Averick's start to the video. I already got it going. That's the background music. Is that my intro music?
Yeah. Oh my god, we should make a theme song.
All right, let's do this review, shall we? Great idea.
Yeah.
All righty. So again, just two sections, just 9.1 and 9.2. Remember, there's going to be two different types of questions when I ask you if, to kind of talk about the R value. The first one being, I say use table 11 to determine if the R value is significant, right? To determine if the R value is significant. Notice that is again different from running a hypothesis test on your R value. Okay, it's different because the table 11 not only tells us that just two levels of significance, and that really doesn't tell us whether there is a positive, negative, or no correlation with we need hypothesis testing for that. Okay, and remember the hypothesis testing is for the population, the row. And then section 9.2 is just linear regression. You can use your graphing calculator to do so. So let's just get right to it. Calculate the coefficient for the data below. Describe the type and interpret the correlation in context of the data. The ages of 11 children and the number of words in their vocabulary are shown. Is their correlation significant at the 0.01 level? So I'm going to open up my calculator here. Remember, you go stat edit. Again, you don't need to use the formula here. Let's just calculate this. 1, 2, 3, 4, 5, 6. 3, 5, 2, 4, 6. 3, 220, 540, 1100, 2100, 2600, 730.
I find every word of a 6-year-old.
All right. So there's my table all plugged in. I'm just going to go back through and spot check. Okay. 64253, 64256. Okay. 25, 12, 260, 22, 730, 2600. Looks pretty good to me. Just double check 3, 220, 540, 1100, 2100, 2600, 730. Okay, cool. So let's go back out to the home screen. Again, we run stat, calc, 4 for my linear regression. And that tells me my R value. Now my R value here is 0.97887. So let's just say 0.979. 0.979. 0.979. There is my R value. Okay. Now, what does that mean in terms of my context? What's that mean in terms of my context? I can say that there is a strong positive relationship that as age increases, the amount of vocabulary size increases as well. The amount of words they know increases as well. Then I have to go to my table 11, which I should probably make a couple more copies just for us, because again, this is not in the yellow packets that I give you. This is just for just us using this chapter here. I say at the 0.01 level, is that correlation coefficient significant? Okay, so 0.01 level. What's my n in this case? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So now remember that I don't need to subtract anything, do I? No, that's just asking me for n straight up. So I'm going to look at n at the 0.01 level, and I see that n at the 0.01 level is 0.735. 0.735. And so because 0.979 is greater than 0.735, we can say that it is significant. Make sense? Yeah.
So when do you know, when to use table 11 and which one to use, the T table?
I will say, within the context of the question, use hypothesis testing and T-scores to The height of 8 high school girls and their IQ, the score and IQ test are shown. Is there correlation? Ooh, thanks. That's usually loud. I think we're safe. For anybody that's watching at home, I just almost broke the TV.
So why don't we do
What's wrong?
why don't we do -2 for table 11?
Because that I'm not talking about degrees of freedom for that. It's just that. Yeah. What's that? Yeah, the only time we do the n-2 is when we're talking about degrees of freedom when we go into the T table. That makes sense?
Yeah.
The height of 8 high school girls and their IQ score are shown. Is their correlation significant at the 0.01 level? Let's find the R value. Stat, edit. And again, you go up, clear down. Clear down. Okay, we got 62, 58. Oops. Sign in there. 58. 65, 67, 59, 64, 65. And then my L2, 109, 102, 107, 114, 96. 110, 116, and 128. Okay, I'm gonna go stat calc 4. Ooh,
That's bad.
our value is 0.05. Is that a strong correlation?
No.
No.
Very
So we can say, how does that relate to my data? We can say that there's relatively no correlation between height and IQ score. I guess that should have been as
Yeah.
expected, right? And I don't even need to look at my table. I know that's not, there's no way. You know, I guess looking at a 0.01 level with n equals 8, I would be comparing it to 0.834, but obviously not greater than. So 0.05 is not greater than 0.834, whatever that was. So it is not significant. I cannot draw any conclusions based on that. Questions about that? All right, let's take a look here. So weights of 8 vehicles and the variabilities of their braking distances when stopping on a wet surface are shown on the table. At the 0.05 level, is there enough evidence to conclude that there is a significant linear correlation between vehicle weight and variability in braking distance on a wet surface? I guess I should have been a little bit more specific. I probably should have said in this, use a hypothesis test to determine, because I wanted to do that. I didn't do that in the other one, did I? No. Okay. Well, I guess I should have, right? I guess I should have said that. Use hypothesis testing in T-scores, because that's what I'll be saying within the context of the problem tomorrow. All right. Now, if I say that there is a significant linear correlation between weight and variability, what is my null and what is my alternative hypothesis? What is my null and what is my alternative hypothesis? Do we remember? Well, null has to have the equality in it, right? So I'm going to say rho, which is that cursively looking p thing, is equal to 0, right? Because if rho is truly equal to 0, there is no correlation, right? So if I can prove that statement wrong, then I can say that there is some sort of linear correlation. So what is this? What is the alternative then? That rho is not equal to 0. This is if I'm just trying to show a significant linear correlation. What if I was trying to show a positive linear correlation? What would be the null then? Less than or equal to 0, right? Because I would be trying to prove that statement wrong, that it would be less than or equal to 0, right? If I was trying to show a negative linear relationship, my null would be greater than or equal to 0, because I'm trying to prove that wrong. I want to try to be negative. So I want to put the greater than or equal to 0 in the null to try to dispute it, to try to disprove that. Okay. So I have my null and I have my alternative hypotheses. I can see the alpha 0.05 level, right? This is a two-tailed test, obviously. Is there enough evidence to conclude that there is a significant linear correlation between the vehicle weight and variability? So I need to figure out my R value, right? Because my T score, chapter 9, my T score is going to be generated with R over square root of 1 minus R squared over N minus 2, where my degrees of freedom is N minus 2. See, now this one I would be subtracting 2 from that, from N, to get my degrees of freedom. But I need to figure out what R is. So let's go in our calculators and do so. Stat, oops, not calc, edit. We clear down. Okay, I'm just going to punch everything in now. 580, 590. $59.40, 600, 100. Looks like I've got 7. Uh-oh, did I forget one? Oh, 58.50. I didn't even do the last one. Whoops. There we go. And then 2.92, 0, 4 point, oops, that's a 3. 9, 1.72, 2.88, 2.3, 2.32, 2.7. All right, so now I'm going to run my regression. Stat count 4. And that gives me my R value of 0.955. I'll say 0.955. And that's all I need to do to create my t-score. Now, I guess it would be a good idea to do my rejection region real quick. Now, for my rejection region, again, alpha is 0.05. And my degrees of freedom, so alpha 0.05. And my degrees of freedom, what is my degrees of freedom in this case? 6. Yeah, I've got 8 total as my n value, so 6. So I'm going to go to my t-table. I'm going to say n is 6 at the, what is it, 0.05 level? And this is a two-tailed test, correct?
Yes.
So this is a two-tailed test at a 0.05, which is a 2.447. 2.447.
The number of things tested. What's this thing for?
N?
DI.
Degrees of freedom.
Oh, is that?
Yeah.
Holy.
So I know now this is a two-tailed test. So really this is a plus or minus, right? So I can say if t comes out less than negative 2.447, or if t comes out greater than positive 2.447, then I can reject my null. Those are my two options. If it comes out less than the negative 2.447 or greater than the positive 2.447, I can reject the null. Let's see what t actually is. Again, t is equivalent to that r value, 0.955, divided by the square root of 1 minus 0.955 squared over n minus 2, which again, in this case is 6. Let's run that value. I'm going to go in the bottom first. 1 minus 0.955 squared. Divide that by 6. Square root it. And I've got 0.955 divided by that. Oh. There we go. Whoa. Is that what you guys got? Maybe. Oh, let me run that calculation again. Yikes, that's giant, isn't it? Okay. Let me just do that again. 1 minus 0.955 squared. divided by 6. Okay, square root it. 0.955 divided by that. Yeah, 7.89.
Okay.
Okay. Am I going to reject my null?
Yeah.
Heck yeah, I am. Quite strongly.
That's a correlation.
So 7.89. Because 7.89 is bigger than 2.447, we can reject the null. Now, let's make a statement, because we always have to make a statement in the end, in context. So what am I studying here? I'm studying the weight of a car and their stopping distances, right? So I can say that there is a strong correlation between stopping distance and weight of the car. Which, I mean, makes sense.
Wait, so can you explain how you got the null again?
There are really 3 options that you have. If you want to show that there is a relationship, right? Not signifying that it's positive or negative, then you just want to make your null equal to 0. Because that is no correlation, right? And I want to disprove that there's no correlation. So therefore, my alternative is rho is not equal to 0. Okay. If you want a positive relationship, right, that means you want to reject the fact that rho is going to be less than or equal to 0, because that would make it negative. So therefore, the alternative, which you would hope to accept, is that rho is greater than 0, positive r bar. And if you're trying to show a negative relationship, it's really just the opposite of that. That the null is going to be that rho is greater than or equal to 0, because you don't want to show it's positive. You want to disprove that statement. So therefore, rho is less than 0. Make sense? Those are your 3 options.
Do we know which option we want to do?
Based on the wording. Yeah. If I say, I want to show that there is a strong positive relationship. I want to show that there's a strong negative relationship. But in this one, I had said, I want to show that there is a significant linear correlation. Just a correlation. Not necessarily positive or negative, just I'm showing that there is a correlation.
Okay.
All right, let's take a look here. The number of goals scored and the number of wins for the top 10 teams of the 2016-17 English Premier League season are shown in the table. So I've got goals along the top and then wins along the bottom. Obviously, what do you think? More goals you score, more wins you have, right? So let's figure out my my linear relationship, or my linear regression, and then we will solve. Oops, no, I didn't want to do that. I want to go stat edit. Oops. Clear this. Clear this. Okay, so we got 85, 86, 80. I thought I was going to do 55. We got 30, 26. $12. Okay, so let's see. Okay, do I have a relationship? Yeah, pretty strong positive relationship, right? Which was to be expected. Okay, the fact that I'm going to score more goals basically is going to mean that I'm going to win more games, right? Okay, so here's my linear relationship. Y is equal to 0.345 x minus 3.326. Now, you could just go in and plug in those three x values and figure out what you get for y. Totally. That would be totally fine. And then plug in 25 for y and figure out what you get for x. But I like using my calculator. So I'm going to go into my y equals. I'm going to clear out everything that's there. I'm going to keep plot 1 on because I want to see my scatter plot. And I'm going to plug in my regression line, non-rounded regression line. And how I do that is I go vars, scroll down to statistics, choice 5, hit enter on that, and then go to EQ for regression equation. And then it plugs it right in for us here. When I go to graph it, I'm going to hit zoom stat. I think it's zoom 0 for me, or zoom 9 or something like that. Zoom 9, there it is. And it's going to show me my my scatter plot as well as my regression line. We see the positive sloping trend, right? All right, the nice thing about this is that I can tell second calculate 50. Oh, sorry, oops. Second calculate value of 50. Okay, 13.94. So 13.94. I can predict that you're going to get about 13.94 wins if you only score 50 goals. Second calculate value of 70. If you score 70 goals, you're going to get about 20.85 wins. 95 goals. Now I'm going to do this one. Second calculate value of 95. What do we got to do? Zoom out, right. That's just saying that 95 is not in my window. You could either zoom out or just manually change your window. I'm just going to hit zoom out. Zoom 3. Enter. All right, so now we can calculate the value of 95, which is 29.48. 29.48. That is probably enough to win you the season. 29 wins, that's 3 points a win. That's 60 to 90 points. That's going to be a win. They're going to win the season. Predict the amount of goals a team must score to win 25 games. Okay, so that's a y value, correct?
Correct.
So I just go in and I hit y equals 25 because I want to know 25 wins. Okay, I'm going to graph that again, and I need to find the intersection. Second calculate, intersection, choice 5. And then it's going to ask me first curve, second curve, and a guess. Enter, enter, enter. 82.03 goals. Sound good? We good?
Sounds solid.
All right, let me turn off the video.